We are the USF wireless cell phone chargers.
My name is Bradley Barnett, and I'm in charge of the oscillator and power amplifier design, as well as troubleshooting.
I'm Randall Betterly. I'm in charge of the coil design, physical construction, and the PCB layout.
I'm Tatsuya Hirazawa. I'm responsible for regulator, rectifier design, and research.
We built a wireless cell phone charger using inductive coil.
The reason why this project is needed is because it's based on convenience. It is also a good representation of the skills learned for our electrical engineering degree at USF.
The design is powered by a 15-volt power supply that is connected to the wall outlet. This power supply is fed into a Colpitts oscillator that oscillates at 170 kHz. Unfortunately, the current it produced was not large enough to turn on the power amplifier, so we needed a preamplifier. An emitter follower serves the purpose of increasing the current. The emitter follower is fed into a Class B amplifier. We chose this design over the Class A and Class AB because it is more efficient. Even though the Class A and AB have higher fidelity, distortion is our least concern and is mostly eliminated by impedance matching.
The output of our power amplifier is fed into the input of our transmitting coil. These coils are wound around pot cores which are made from a ferromagnetic material. We decided to use a 10-to-10 turn ratio on the coils because they provided the most efficient configuration. We also tested a variety of different wire gauges, but 26 gauge proved to be the best since it wasn't as fragile and fit into the pot cores easily. The coils are flush against the cases to provide an efficiency that is greater than 90%.
The receiver coil is fed back into the input of a full-wave bridge rectifier. In parallel to the rectifier inputs are several capacitors that serve to match the impedance. At the output of the rectifier, we have a smoothing capacitor as well as a shunt resistor. This resistor adjusts the voltage to the desired 5 volts. It is also large enough compared to the phone resistance so that the most of the current flows into the phone. As you can see here, we have 100 milliamps charging into the phone. And over at the oscilloscope, we have it at 4.3 volts. Here's our finalized product shown inside the cases. The larger box is our charging pad and the smaller box connects to the back of the phone. For commercial use, the smaller box will be built into the phone or phone casing. Shown inside both boxes are the solder designs. The coils are glued into the top of the case surrounded by magnets to lock the phone into place. This nearly perfectly aligns the coils for maximum power transfer.
This is a demonstration of our wireless charging unit in action.